Have you ever wondered about the sheer power and potential of AI in today's world? It's a question that's becoming increasingly relevant as we witness the transformative impact of artificial intelligence in virtually every sphere of our lives. From healthcare, where AI is being leveraged to diagnose diseases with unprecedented accuracy, to finance, where complex algorithms are forecasting market trends and informing investment decisions. But it's not just these sectors. AI is revolutionizing industries across the board, driving efficiencies, improving outcomes, and acting as a catalyst for innovation. It's transforming the way we work, the way we learn, even the way we interact with the world around us. The power of AI is immense, and its potential is only growing. As we move forward into a future where AI continues to shape and define our society, it's clear that understanding this powerful tool is no longer an option, it's a necessity. One of the most fascinating aspects of AI is its ability to understand, generate, and interact using language. But have you ever wondered how a text-based AI model is trained? Text-based AI, sometimes known as natural language processing or NLP, is the technology behind many things we take for granted. Think about chatbots that help answer your queries, virtual assistants like Siri and Alexa, or even your email spam filter. These all rely on text-based AI. Now, how is it trained? Well, it's a bit like teaching a child to read. The AI is fed vast amounts of text data from which it learns to understand the patterns and structures in the language. It learns the context, the grammar, and even the nuances of sarcasm and humor. It's a complex process involving a lot of data and computational power. But the result is an AI that can understand, generate, and even interact using human language. Now let's delve deeper and understand the process of training these models. The first step to train a text-based AI model starts with collecting data. Often compared to the fuel that powers our vehicles, data is the lifeblood of any AI system. It's like the food we eat. It nourishes and strengthens the AI, enabling it to learn, grow, and make increasingly accurate predictions. The more high-quality data we feed it, the smarter our AI model gets. But where does this data come from? Well, it's all around us. In the digital world, we're surrounded by a wealth of information that can be used to train AI models. Think of all the books ever written. Each page, each paragraph, each sentence is a potential piece of data. Books are a treasure trove of diverse linguistic styles, from the eloquent prose of classic literature to the concise clarity of modern nonfiction. They offer a wide range of topics, tones, and perspectives that can greatly enrich the training of a text-based AI model. But books are just the tip of the iceberg. The internet is an even larger repository of data. Websites, forums, social media posts, online reviews, the list goes on. These sources offer a real-time snapshot of human language in all its dynamism and diversity. They provide a wealth of colloquial expressions, slang terms, and other linguistic nuances that are often absent in traditional texts. Then we have structured databases. These are collections of information that are organized in a way that a computer can easily access and manipulate. Databases can contain a wide variety of data types, from plain text to numbers, dates, and more. They provide a highly efficient way to store, retrieve, and analyze data. However, the key to effective training is not just quantity, but quality and diversity. We need to ensure that our data is representative of the vast range of human experiences and perspectives. This means including data from different regions, cultures, and demographics, and covering a wide variety of topics. Once you have enough data, the next step is pre-processing. Data pre-processing is a crucial step that prepares your data for the model. Just as a chef meticulously prepares ingredients before cooking, we must also prepare our data before feeding it to our AI model. This step is not just about tidying up, it's about transforming raw, unstructured data into a format that the model can digest and learn from. First, we need to clean our data. This involves removing any inconsistencies, errors, or irrelevant information. Imagine trying to read a book filled with typos and irrelevant footnotes. It would be quite a struggle, right? It's the same for an AI model. If we feed it unclean data, it may struggle to make sense of it, affecting the accuracy of its output. Next, we delve into the concept of tokenization. This is the process of breaking down text into smaller units or tokens. Think of it like splitting a sentence into individual words. For example, the sentence "I love AI" is tokenized into 3 tokens: I, love, and AI. By doing this, we're making it easier for the model to analyze the text. Once we have our tokens, we need to convert them into something the model can understand: numbers. This is where vectorization comes in. Each token is represented as a numerical vector in a high-dimensional space. It's like assigning a unique address to each word in a city of words. This allows the model to understand the relationship between different words and their meanings. Finally, we standardize our data. This is like translating everything into a language the model understands. It's about ensuring consistency so the model isn't confused by different formats or scales. And voila, our data is now pre-processed. It's been cleaned, tokenized, vectorized, and standardized. We've transformed a jumble of raw text into a structured format, ready to be devoured by our AI model. And remember, data pre-processing isn't a one-size-fits-all process. It's flexible and adaptable, much like a recipe. You can tweak it depending on the needs of your model and the nature of your data. After pre-processing, the data is ready to be fed into the model. And much like a well-prepared meal, it's set to nourish the learning process of our AI, helping it to grow smarter with each bite. Now comes the exciting part: training the model. Imagine our text-based AI model as a student, eager to learn from the data we've collected and pre-processed. This is where the model starts to pick up patterns and structures from the data, a process we call training. Let's break down the training process a bit. We feed the model our data in iterations known as epochs. Each epoch is a complete pass through the data. Think of it as a school year, where the student, our model, goes through the entire curriculum. Now, we don't want our model to simply memorize the data. We want it to learn to understand the underlying patterns. That's where the loss function comes in. The loss function measures how well our model is doing, how much it's losing in its predictions. It's like a teacher grading a student's performance. The lower the loss, the better our model is performing. But how does our model learn from its mistakes? Enter backpropagation. Backpropagation is a mechanism where the model adjusts its internal parameters, akin to a student revising their approach after receiving feedback. It's a way for the model to correct its course, to improve its performance over time. However, training a model isn't just a set-it-and-forget-it process. It requires careful tuning of hyperparameters, variables that we set before the training begins. These include the learning rate, which determines how fast our model learns, and the batch size, which is the amount of data the model sees in one go. Hyperparameters are like the rules of study for our model student, guiding its learning process. Remember, patience is key here. Training an AI model isn't a sprint, it's a marathon. It might take time, depending on the complexity of your model and the amount of data you have. But once it's done, once all those epochs have passed, and all that backpropagation has happened, you're left with something truly remarkable. Training might take time, but once it's done, you have a model that can understand and generate text. The last step is testing the model and fine-tuning it. Once we've trained our model, the next crucial stage is to test it. But we're not testing it on the same data we used for training. Oh no, we're using unseen data, data that's fresh and new to the model. This is how we evaluate the model's performance. Think of it as a pop quiz for the AI model. We've given it all the training, all the lessons, and now it's time to see how well it has learned. We're looking to see if it can take what it's learned and apply it to new, unseen data. But why do we do this? Why not just test it on the training data? Well, that brings us to the concept of overfitting. Overfitting is like memorizing the answers to the quiz instead of understanding the concepts. If a model is overfit, it performs really well on the training data because it's seen it before, but when it comes across new data, it stumbles. This is why we test on unseen data. We want to ensure our model isn't just memorizing, but learning and generalizing. Generalizing is the ability of the model to take what it's learned and apply it to new data. It's the ultimate goal of any AI model. But what if our model isn't performing well on the unseen data? That's where fine-tuning comes in. Fine-tuning is like giving extra coaching to the model, helping it to improve in the areas it's struggling with. We adjust the model parameters slightly, retrain it, and then test it again to see if performance has improved. It's a cycle of training, testing, and fine-tuning until we reach a model that performs well on both the training and unseen data. Remember, the goal is not to create a model that just performs well on the training data. We want a model that can generalize, that can take what it's learned and apply it to new data. It's a challenging and iterative process, but well worth the effort. And voila, you now have a trained text-based AI model. Training a text-based AI model might seem daunting, but it's a systematic and rewarding process. We've come a long way, haven't we? Let's take a moment to appreciate our journey. We started by collecting data, the raw material for our AI model. Gathering diverse, high-quality text is crucial to imbue our model with the knowledge it needs to function effectively. Then we moved on to data preprocessing. This step involves cleaning and organizing the data, transforming it into a format that our AI model can readily digest. Next, we dove into the heart of the process, model training. This is where our AI model learns from the processed data, gradually improving its language understanding and generation abilities. Finally, we tested and fine-tuned the model, an essential step to ensure its performance and adaptability. Remember, the power of AI lies in its ability to learn and adapt. And with these steps, you've just taught it to understand and generate language. Fascinating, isn't it?